Hello dear students, welcome you all. In this video we are going to study different types of milling machine operations and we will study how they perform. So let's start. The different operations can be performed on milling machines, that is like plane milling operations, face milling operation, side milling operation, straddle milling operation, angular milling operation, gang milling operation, form milling, that is profile milling operation. The next is end milling operation, saw milling operation, and T-slot milling operation. Now we study these all types of operation and we will study how they perform. The first one, that is plane milling machine, plane milling operation. So it is like a operation of producing plane, like it is will be the flat or horizontal surface which is parallel to axis of rotating plane milling cutter. You can see in this figure. For this operation, the workplace or workpiece surface is mounted parallel to the surface of the milling machine table. The milling cutter is mounted on the milling machine arbor and the rotated at a high speed. The arbor is well supported in horizontal plane between the milling machine spindle and one or two or more arbor supports. The depth of the cut is adjusted by rotating the cross feed screw of the table, and the operation also known as slab milling machine. So you can see the slab, that means the flat surface which is manufactured in this kind of milling operation. The next is face milling operation. As you can see, the like in turning operation we are doing a facing, that means we are decreasing the length. So similarly the height of the workpiece is decreasing. So face milling is milling operation that are perpendicular to cutter axis. Face milling produces flat surface. This operation is performed by face milling cutter which is mounted on the stub arbor of milling machine. As you can see in figure, the peripheral cutting edge of the cutter do the actual cutting, while the face cutting edge finish up the work surface by removing a very small amount of material. In face milling, the feed can be either horizontal or vertical. The depth of the cut is adjusted by rotating the cross feed screw of the table. The large surface are generally face milled on the vertical milling machine with the workpiece clamped directly to the milling machine table to simplify handling the clamping operation. The next is side milling. The side milling is operation of producing of flat vertical surface on the sides of the workpiece by using side milling cutter. The depth of the cutter adjusted by the vertical feed screw provided on the table. So you can adjust the workpiece by using the feed that screw. The next is straddle milling operation. This is a type of milling operation we can see in figure. In this milling operation, when two parallel vertical surface are machined simultaneously by two side milling cutter mounted on the same arbor, the operation is called as straddle milling operation. You can see the two milling cutter which are mounted on the one single arbor. The distance between the cutter is adjusted by the both sides of the workpiece can be milled simultaneously. So you can adjust the distance between the two arbor and you can change the length of the workpiece. The two side milling cutters are separated by spacer. So you can see here spacer, the spacer which is used for the adjusting the distance between the cutting teeth of the cutters, which is exactly equal to the width of workpiece area required. So usually 2.5 sides of milling cutters are used so that they are straddle the workpiece. The workpiece is usually mounted between the centers of the index and fixture or mounted vertically in a swivel wise. The next milling operation is angular milling operation. So angular milling is milling of flat surface which are neither parallel nor perpendicular to the axis of the milling cutter. A single angle or double angle milling cutter is used for this operation. You can see the double angle milling cutter in this figure. The milling dovetails, that is V-shaped groove, is example of the angular milling operation. The next one is gang milling. The gang milling is the term applied to the operation in which two or more milling cutters are used together on the one arbor for machining number of horizontal surface. So you can see two or more, or you can see the more than one it may be 2 or 3. So this machining numbers of horizontal surface of job. So all cutters may perform the same type of operation, or each cutter may perform different types of operation. So that's why it's called as gang milling operation. The diameter of cutter may be same or the different. The cutters are mounted on the arbor of plain milling machine. The distance between the cutter is correctly adjusted by means of spacing collars. For the example, several workplaces need a slot, so that for that flat surface we use the gang milling operation. The next is form milling. The form milling is operation of producing irregular surface by using form cutter as shown in the figure. It is process of machining special counter composed of curves and straight lines, or entirely of a curve, which will be at a single cut. This is done with the perform milling cutter or shape to the counter to the cut. Depending on the shape of the surface to produce, the form cutter is chosen. The irregular surface may be convex, concave, or any other type of shape. So other jobs are performed milling cutters include milling intricate pattern on the workplace and milling several complex surface in a single cut, such as are produced by the gang milling. So in this milling operation, the cutting of gears can be done by this kind of milling operation. The next is end milling. So end milling is operation of producing a flat surface which may be vertical, horizontal, or at a angle. The cutter used is an end mill cutter. The end mill cutter are also used for producing slot, grooves, or keyways. The next is slot milling. The operation of producing keyways, grooves, slots of varying shapes and sizes is called as slot milling operation. Slot milling operation can be used any type of milling cutter like plain milling cutter, metal slitting saw, or side milling cutter. The selection of cutter depends upon the types of size of a slot or groove to be produced. So right placement of milling cutter is important in this operation, so that axis of cutter should be at the middle of geometry of the slot or groove to be produced, so that we can get the desired shape. The closed slots are used by the using end milling cutters. So for milling dovetail slots or T-slots, a special type of cutter is used. This operation is performed in 2 steps. First, by using end mill or plain mill cutter, and plain slots are produced. The T-slot cutter is used to enlarge the face of bottom of the slots. Next is T-slot. You can see in this figure the cutting T-slot of workpiece holding device in typical milling operation. So the size of T-slot depends upon the size of the T-slot bolts which will be used. Dimensions of T-slots and T-slot bolt are standardized for specific bolt diameter. 2 milling cutter are required for milling T-slots and T-slot milling cutter, and either the side of milling cutter or the end milling cutter. The side milling cutter or end milling cutter is first used to cut a slot of workpiece equal to the width to the throat width of the T-slot. So the position of the T-slot milling cutter over the edge, you can see the workpiece and align it with the previously cut sleeve. The T-slot milling cutter is then used to cut the head space to the prescribed dimensions. So feet of the table, similarly the longitudinally to the make the cut. So to use good amount of cutting oil between the cutter and work producing the operation, so that we can get the maximum finishing. And the last one is slitting. So saw milling operation produce narrow slot or groove into the workpiece using saw milling cutters. This operation is also used to cut the workpiece into the equal or unequal piece which to be cut, or you can say the parting off, means making 2 or more parts. In case parting off operation, cutter and workpiece are set in a manner so that the cutter is directly placed over the one of the T-slots, so that the workpiece is we can make in 2 or 3 parts. It is operation of parting off the solid piece into 2 parts or cutting narrow slot and groove. The workpiece is required to be rigidly held in the work holding device, so that we get the slitting operation. Slitting saw is used slitting operation. So we have studied the different kind of milling machine operations. So in exam you will get a similar type of question, or that time you have to explain the milling operation one by one. That's all. Thank you. Bye bye.